Hello, calculus teachers. My name is Tracy, and I'm a math teacher in residence at NumWorks. In this video, I'm going to introduce the NumWorks calculator and demonstrate how it can enhance your classroom experience. For those of you new to NumWorks, the NumWorks calculator was made by teachers for teachers. You can now spend less time troubleshooting and more time engaging with your students. In addition to the handheld calculator that is approved for all AP exams as well as the SAT and ACT, the NumWorks also provides a free online calculator and mobile apps. Not only are these great for classroom presentations, they also provide your students with a continuous access to the calculator. Today, I'll be using the online emulator, and I invite you to join me on your handheld calculator or by navigating to numworks.com/simulator. The NumWorks Graphing Calculator utilizes a familiar app-based interface. There are 3 apps relevant to the AP Calculus AB course. The Calculation app is great for calculating values in the mathematical notation exactly like on your paper. The Grapher application, you can construct beautiful graphs in the perfect viewing window and easily find key points. It offers amazing visuals for derivatives and integrals. In the Equation application, you can solve any equation with the press of a button. Let's dig into these apps. The first application we're going to look at is our Grapher application. Let's press OK to open the application. The Grapher application is split into 3 tabs along the top: Expression, Graph, and Table. To plot a graph, we must first add an expression in the Expression tab. Click OK to add an element. You can start typing here right away, or you can go over and use a template to help you get started. Let's go over and press OK to use a template. And use the f of x equals x template to create a function. Let's edit this template to create the polynomial function f of x equals 2x cubed minus 5x squared minus 16x plus 15. Press OK to confirm your function. To view the graph of your function, navigate to the Graph tab and press OK. Right away, you can view the graph in a window that is automatically calculated based off of interesting points on the graph. You can also use your plus and minus key to zoom in and out of your graph. You can use your left and right arrows to move along the graph. As you navigate the graph, the cursor will snap to the black interest points, including maximums, y-intercepts, zeros, and minimums. You can also use your store arrow to store x values from this screen. For example, if I want to store the x value of the minimum, I can press the Shift key, followed by the x to the y key, and use my alpha keys to create the variable a. Let's start to look at some of the calculus visual tools we offer in the Grapher application. As a calculus teacher, you will frequently use your toolbox key. The toolbox key is located right below the OK key. This will house all of the calculus features that you need. Let's press the toolbox key now. This brings you to a Calculate menu on the f of x curve. The first calculus feature we're going to explore is in the Find menu. Navigate down and press OK. Here, you can find a lot of useful things to help students explore functions like x given y, extreme values, zeros, tangent lines, and integrals. Let's take a look at the Tangent Finder first. Press OK on the tangent. This screen allows you to turn your tracer into a tangent line. This is a great tool to help students build their understanding of slope. The bottom banner will also display everything you need to write both point slope form and intercept form of the tangent line. You can also use your number pad to jump to specific x values. For example, typing -2 and then pressing execute will give us all information for the tangent line when x is -2. Press OK or back to return to the graph and out of the Tangent Line Finder. Now that we have a great visual understanding of tangent lines, let's keep looking at some derivative visuals. We're going to press the toolbox key and this time head to the Options menu. The options have great features like color and plot restriction, but let's take a look at the derivative section. Here we have some important toggles. The value of the first derivative will add the values of f prime of x to the bottom banner as you trace the graph. Plot of the first derivative will create a graph of the first derivative as well as turn on the values of the first derivative. Note that there are second derivative options here as well, but we'll just look at the first derivative. Pressing the back key 3 times will get us back to the graph. Now we can see the graph of f prime of x. Notice how I traced the graph of f of x and the bottom banner displays f prime of x values. We can also explore how the maximum values of f of x correspond to the zeros of f prime of x. Let's explore the Table tab next. Navigate up and over to the Table tab and press OK. In the table of values, you can see columns x, f of x, and because we toggled on the derivative, we can also see f prime of x. By default, the table has x values 0 to 10. You can edit any of these values right away, or you can use the Set the Interval submenu to select a very specific table. The last thing that we're going to look at in the Grapher application is integrals with functions. Before we do this, let's add another function to our expression list. Navigate back to the Expression tab. Notice that f prime of x is an element in the Expression tab. Let's remove this by pressing the Delete button. Now we just have f of x graph. Let's add an element, use a template, and grab the g of x template. We'll edit this template to create g of x equals 3x minus 4. Press OK to confirm our graph. Now we can look at these graphs of these two functions in the Graph tab. To explore integrals, we need to press our toolbox key again and navigate to the Find menu. Down at the bottom, we have an integral, and because we've added a second function, we can also find the area between f and g. Let's choose the area between option by pressing OK. The bottom banner prompts us to select a lower bound. You can use your number pad to input a value or your left and right arrow keys to scroll. I want to find the area bounded between, so I'm going to use my arrow keys to scroll to the first intersection and press OK. Now, to select the upper bound, I'll use my right arrow key to scroll to my third intersection and press OK. Now we have the calculated area between f and g. The next application that we're going to explore is the calculation application. Press the Home key to navigate back to our home and over to Calculation app and press OK. Here you can perform a variety of computations. For many calculations, NumWorks will display multiple representations of a solution. For example, 1/2 plus 2/3 will display both 7/6 and the decimal approximation of 1.6667. The square root of 50 will show 5 root 2 and the decimal approximation of 7.07. Sine of pi over 3 will display root 3 over 2 and its decimal approximation as well. Some calculations even have additional results available. Just navigate up into your history and over to the 3 dots. Here you can see the additional results. Like for trig, you can see the value displayed on the unit circle, and down below you have the sine, cosine, and tangent values. I'll back out of my additional results now. You can also do computations with stored functions. For example, if I want to find the average rate of change of f of x from 1 to 5, I can start by pressing the division key twice to create an empty fraction template. Then I can press the var key to access my stored function f of x. Then I can input f of 5 minus f of 1 over 5 minus 1. Press execute to see your computation. Now let's look how to compute a derivative at a point. Remember, the toolbox key is very important for calculus. Let's press the toolbox key to access all operations that don't have their own button. Here you can find advanced operations like the absolute value, the nth root, and log base a. From there, advanced operations fall into categories. You can access all calculus operations within the calculus section by pressing OK. First, let's look at our derivative options. You can evaluate a derivative or an nth derivative. Let's first compute a derivative by pressing OK. Start by inputting the expression you want to find the derivative of using your x and t key. Let's compute the derivative of x squared minus 5x at x equals 2. Now, to compute a higher order derivative, you can either edit an existing derivative or use the template from the toolbox. Let's go up into our history and press OK on the derivative we just computed. This brings the expression to the input field. You can navigate now to the dx component and add an exponent in the numerator or denominator. Let's use the square key to change this to a second derivative and press execute. You can also compute an nth derivative using the operation in the toolbox. Let's press the toolbox key again. Note that we're still in the calculus menu. Press OK on the nth derivative. Here you need to input your expression, derivative level, and the x value. Let's compute the third derivative of cosine of x at x equals pi over 2. The last way to compute a derivative is using the prime notation on a given function. Let's grab the f of x function again from our var key and navigate to in front of the parentheses. To add the prime, we'll use the alpha key followed by the toolbox key to access a single prime mark. Then navigate to the right of the parentheses and input your x value, for example 5, and press OK, or execute. This computes the first derivative of f of x at 5. You can also use the alpha toolbox key to add additional prime marks if you would like to compute higher order derivatives using this notation. The last calculation you will need to know how to compute is an integral. This calculation can be accessed again from your toolbox. Press the toolbox key and navigate to the integral option and press OK. For this computation, you need to input your bounds and integrand. Let's compute the integral from -5 to 7 on the arctangent of x. To access the inverse trig, use the shift key followed by the tangent key. If we want to instead find the total area, you can quickly change this integral by navigating up and pressing OK to re-grab the integral. Navigate to the beginning of the function. Press the toolbox key to access your advanced operations and back out of the calculus menu and press OK on the absolute value. Notice that the absolute value covers the entire arctangent of x function. Now press OK. The last application we'll explore is the equation application. Press the home key and navigate to the equations application and press OK to open up the app. Within the application, you can use your keys to start typing equations right away. For example, we can solve the equation x cubed minus 5x plus 4 equals 0. To access the equal sign, use your shift key followed by the pi key. Confirm your equation and navigate down to Solve the Equation button and press OK to see the solutions. You can also solve derivative and integral equations using the equation solver as well. Let's go back and delete the first equation. Let's find where the second derivative of x is equal to 0. To do this, use the var key to grab your f of x function, navigate before the parentheses, and press the alpha toolbox key twice. Navigate before the parentheses and input the variable x. Now, at the back of our second derivative, we're going to use the shift pi key to input equals and then 0. Press the OK or execute to confirm your equation and then go down to solve the equation and press OK. Here, you can see the values that make the second derivative of f of x equal to 0. I hope this video demonstrates to you some of the many ways that NumWorks Calculator is the perfect calculator for AP Calculus. If you're a high school math teacher, you can request a free sample calculator. Simply head to num.works/community to claim your free calculator now. Thank you for watching. If you have any questions, please don't hesitate to contact us at contact@numworks.com.